Now let's go to the next kind of differential equation, the homogeneous differential equation. So now we define homogeneous differential equation if f tx ty is equals to t to the power of n, f quantity xy for some real number n, then f xy is said to be homogeneous function of degree n. N here is any real number. So now let's go to the example of homogeneous differential equation. So first, find the general solution of this x plus y cot x over y minus y, this dy y dx is equals to 0. So sorry, so we have to prove that this is a homogeneous differential equation. So first we have to change this equation in the form of m xy plus n xy is equals to 0. So transform this in this equation, so we have negative y dx plus y cot of x over y dy is equals to 0. So now we have m, so this is now our m xy and this is our n xy. So m tx ty is equals to t n m t x, so xy. So now we put t here in the equation, so we have negative ty dx is equals to plus ty cot of tx ty dy is equal to 0. So this one we factor out t, so we get t negative y dx plus t y cot of x over y dy is equals to 0. As we can see here that this is the t with the power of 1. So we conclude that this is a homogeneous function of degree 1. Okay, so now we did prove that this function here is a homogeneous differential equation. So now we have to find the general equation of this equation. So first we let x is equals to vy. So now our dx is equal to v dy plus y dv. So this is the crucial thing in here in differential equation, in the substitution of the variables. So here we substitute x equals to vy. So we substitute x equals to vy because mxy is much simpler than nxy here. So if your nxy is simpler than mxy, so we let y is equals to ux. So anyway, we substitute x equals to vy. So now we substitute this into this equation. So we get negative y v dy plus y dv plus vy plus y cot of vy y dy is equals to 0. Multiply negative vy dy minus y squared dv plus vy plus y cot of v dy is equal to 0. So as you can see here, so combine. So we get negative y squared dv plus negative vy plus vy plus y cot of v dy is equal to 0. So here we see that this is equals to 0. So now negative y squared dv plus y cot of v dy is equals to 0. So as you can see, this is a separable differential equation. Anyway, that a homogeneous differential equation can always be reduced to separable differential equation. So we multiply this both side by 1 over y squared cot v. So we get dy over y, which is equals to dv over cot v. So integrating both sides, we get ln of y is equals to negative ln integral of this. So this is negative ln cos. So cot is tan v. So integral of tan is negative ln cos v plus c. So in finding y, we only have to take its natural logarithm. So we get y is equal to e to the power of ln cos v plus c, which is equal to negative, e negative ln cos v times e to the c. So which is equal to, so this is equal to 1 over cos v times c, which is our y. So cross multiply cos v, so we get y cos v is equals to c. So here we have to substitute, which is v is equal to x over y. So substitute this. We have y cos x over y is equals to c. So this is now our general solution of the equation.